14.4 is probability of various permutations. So we're going to talk about permutations number 1, and then we're going to talk about finding the probability of a certain permutation. So that's our essential question. How do you find the probability of getting a permutation if an arrangement is selected at random? Okay, and so first thing we'll do is we'll define what a permutation is. So a permutation, permutation is a set of objects, a permutation of a set of objects is an arrangement in a definite order of some or all of the elements in that set. So there's a definite order. There's a certain thing going in a certain place. Okay, so first example, in how many different ways could you arrange 3 books on a shelf if you have 7 books from which to choose? So we have 3 books. So I like to kind of do it like this. I got 3 spaces. So for the first space, I have a total of 7 books to choose from. So I have 7 possibilities. And then in the second space, I have a total of 6 possibilities left because I've already chosen 1 book. And then in the next space, or the last space, I have a total of 5 possibilities to choose from. And so what you do is you just multiply those. 7 times 6 times 5 will give you 210. And what this is the number of permutations of 7 elements, or 7 books in this scenario. The 7 elements taken 3 at a time. Well, there's another way to do this. This is really 7 permutation 3. So this is an example of this right here. I have 7 elements, and I take 3 of them at a time in a definite order. Okay, order matters here. Okay, so anytime you see something like this, basically what you do is you take the 7 elements, so the number of elements that you have, which is 7 in this situation, 7 factorial, maybe you remember factorial, 7 times 6 times 5 times 4 times 3, and so on. And then in the denominator, you divide that by the number of elements, subtract the number of those elements that you're taking. So this would be 7 minus 3 factorial. Okay, so really this is then 7 factorial over 4 factorial. There's a couple ways to do this, and I'm going to show you both ways. But the first way is by hand. So this is 7 times 6, and you keep going until you get to 4 factorial, times 5 times 4 factorial. I could write 4 times 3 times 2 times 1, but that's the same as 4 factorial. So over here I'm just going to write 4 factorial, and those reduce, and now I'm just at 42 times 5, which will also give me 210 possible permutations. Okay, so that's one way of doing that. Your calculator will also do this, but it is important that you're able to do this without a calculator at times. Okay, so let's see. Yeah, I'll show you that in a minute. Okay, so a permutation is selected at random from letters in the word sequoia. What is the proper probability, that it has letter Q in the 4th position and ends with a vowel? So the first thing that we need to do before we can figure out the probability of this happening, we actually need to figure out what are the total possible outcomes in the sample space that we have here. So we have a total of 1, 2, 3, 4, 5, 6, 7 possible letters that we're going to rearrange. 1, 2, 3, 4, 5, 6, 7. Now, what's the probability that it has letter Q in the 4th position? So let's see, this is the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th. All right, well, for the 4th position, how many possible Qs are there? Well, there's only 1, so it's possible that I get that 1 Q. Okay, I'm going to put that there in the 4th position. That's probably the first. Let me go ahead and write down what I'm doing. So my first step here basically is to look for the number of Qs and put that in its position, which I just did. The next thing I want to look for, it should end with a vowel. So ending, that's the second thing I'm going to look at. Well, let's see how many vowels are there. 1, 2, 3, 4, 5, right? So I've got a total of 5 vowels. So I'm going to say, all right, the second thing that I should do is look for the number of vowels. Well, what does that leave me with? So for the first letter, how many possible letters, if I've taken one of the vowels and put it here, taken the only Q and put it here, then how many possibilities do I have for my first letter? Well, I basically am going to have 5 letters left, right? So that's what I'm going to put in the first position. And then how many letters would I have left to choose for the second position? 4. And how many would I have left to choose for the third position? 3. I've already figured out the fourth position. The fifth position, there's only 2 letters left out of the 7. And then the sixth position, there's just 1 letter left. Okay, so that's kind of, you're thinking through it based on what you've been given, the information that they want in certain places. Okay, so step 4, you just fill in the rest. And then this is a permutation. This is going to give us our total number of outcomes. Oh, I'm lying. This is going to give us the total number of desired outcomes. Okay, so that ends up being, let's see. So basically you've got 5 times 4 times 3 is 60, times 2 is 120, times 5 is 600. So you've got 600 permutations. Those are your desired permutations. Now we need to figure out, okay, well, what's our whole sample space? Well, the whole sample space would be like if I just had these 7 letters and I say to myself, okay, I'm going to put 7 here, then 6, I would have an option of choosing 6 to go here, right? So I pick one letter out of 7. There's a possibility that I get 7 different letters here. Then there's only a possibility that there would be 6 others. And then 5, and then 4, and then, okay, so the number of possible elements in the sample space is really going to be 7 times 6 times 5 times 4 times 3 times 2 times 1, which in fact is 7 factorial. Now you can do 7 times 6 times 5 times 4 times in your calculator, or I can show you how to actually find that on your calculator. So permutation, which is that little exclamation mark on your calculator, that's going to be under math, probability, and then let's see what we got here. Math, go over to probability. It's going to be number 4. Oops, I did that in my graphing calculator, which is not what you want. So I'm going to do 7, I'm going to do math, probability, and then it's number 4. Which gives you 7 factorial. Press enter, and it does the math for you. So 5,040. And that's the total possible outcomes in the sample space. I haven't even answered the question yet. Because the question is asking me, what's the probability that this happens out of all the possible outcomes? So now I'm going to say, well, the probability of the actual event happening that I want to have happen is the number of that event happening, the number of times that event could happen, or the number of permutations of it happening, and then over the number of the sample space. So this right here is really giving me the number of the actual event that I want to have happen. Okay, so I'm going to have 600 over 5,040. And when you do that calculation, you get 11.9%. I'll put an approximation there. That's your final answer. Now let's just go back over one more thing. Like for example, up here, if you notice when we went to math probability, notice that we've got the permutation, the NPR. Okay, so for the NPR, right, where basically that's the number of elements that you have, that's how many you're going to choose at a time. So that would be like this. You're going to go to math, and then probability, and then that was number 2. Okay, so I'll show you how to do that right now. So you don't want to start with that. You're going to start with, I think I'm doing this right, depends on your calculator. So some of your calculators you would start with 7, then put it in, but actually I think in my calculator, let's try it. Yeah, it gives you little spaces to like type them in. Notice I got the 210. Let's see if I can try that in a different mode. So if I go, some of you guys don't have the math print like me, you have the classic, which I can do in my calculator as well. This one, that's like the older calculators. So this one, I think this is where I have to do that. So math, probability, this thingy. Yeah, see, then you put in the 3. And there you go. So if you have the older calculators, you're going to have to type in the N part first, then do the NPR, then do the R. If you have one of the newer calculators, you can just go straight in there and enter in the stuff that you need to enter in the right place. Okay, so I think we've answered both first examples. And then we just have the definitions right here. So just defining what factorial is. Basically, for any positive integer n factorial, which is n exclamation mark, is given by this, where, it's basically you multiply all the numbers, starting with that number. They've done it backwards. They go 1, 2, all the way up until that number. I'm always going to start with that number and then go backwards. It's the same thing, because here it is written the way that I do it. So let's say, for example, we're doing 7 factorial again. This really says, okay, you start with 7. Then you do 7 minus 1, which is 6. Then you do 7 minus 2, which is 5. And so on until you get all the way down to 1. Okay? So this is your definition for factorial, and showing you, oh, there's one important thing here. Maybe you remember, maybe you don't. 0 factorial is defined to equal 1. Just like anything raised to the 0 power is defined to equal 1. All right, so let's do number 12 from your textbook. This is soccer team problem 2. 11 girls try out for the 11 positions on the varsity soccer team. If the players are selected at random, find the probability of each event. So now we want like the favorable over the total number of outcomes. Okay, so for A, Mabel, Keisha, or Deirdre is the goalkeeper. Well, that's 3 out of the total of 11 girls, right? So the probability of one of those 3 becoming the goalkeeper is 3 out of 11. Pretty simple. Now B adds a little more to that. So we've got Mabel, Keisha, or Deidre is the goalkeeper. Well, that's still 3 over 11. Oops, why did I put a comma there? I don't know. And so I want the probability of that event happening and the other event happening. So I'm going to multiply this. Alice or Phyllis is the center forward. Well, that's 2 girls. But if I've already chosen one girl to represent the goalkeeper, then that means I have 10 more girls to choose from, and I'm choosing 2 of those. So I end up with, well, actually this reduces, so 3 out of 55. And you can turn these into percents if you want, or you can leave them as ratios. All right, and then the last one here, You got Mabel, Keisha, or Deirdre is the goalkeeper, so that's still 3 out of 11. Alice or Phyllis is the center forward, so I got that 1/5. I'm going to multiply by 1/5. And B is the fullback. So let's see. I've chosen 2 girls already out of the 11, so that means that there would only be 9 left by the time we get to the fullback position. And we're just talking about B, so there would just be 1. So this is going to be 45 times 11 is 165. So 3, oh, I lied. These reduce. You get 1 out of 165. All right, so those are those probabilities. Now let's talk about permutations with repeated elements. This is actually quite simple. So in this word carrier, there are 7 letters. But in fact, you don't end up with 7 different 7 factorial permutations, because 3 of these R's are indistinguishable from each other. So what I do is, in order to find the number of permutations, I basically take what I would normally find, but then I say to myself, well, I've got 3 things that are indistinguishable, or 3 repeated elements here. So I divide out the 3 factorial. And then you could do this by, again, 2 ways. 7 times 4 times, 7. It's sunny outside. I want to be out there, so I'm not paying attention. 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. These reduce. You're left with 42 times 20, so that's going to be 840. Okay, so a nice quick way to do it. Or you can also use your calculator, and you can go to math. Oh, wait, before I do that, you got to go 7, and that's not 7. I got this, guys. 7, and then math, and then probability, and then 4, okay? And then you divide that by 3, and then math, and then there's your 840 again. So you got a couple ways of going about doing that. Okay, make sure you can do it by hand, though, because there's going to be times where you're not going to be allowed a calculator. You're going to want to be able to do it like this, where you can quickly simplify. Okay, so let's do another one of those. This is number 16 from your textbook. You have 9 pennies are lying on a table. 5 show heads and 4 show tails. You know, do we know which penny is showing heads and tails? We don't, okay? So in how many different ways, such as this, could the coins be lined up if you consider all the heads to be identical and all the tails to be identical? So it doesn't matter which penny has heads, right? Basically, you have 9 pennies total, and you know that 5 of them have heads. Okay, so all the different ways of arranging this would be 9 factorial. But the heads are indistinguishable from each other. So we're going to divide out all the repeated elements there. That's 5 of them, 5 factorial. And then the tails are also indistinguishable from each other, and I've got 4 of those, so I'm going to also divide out the 4 factorial. So how would I do this by hand? I'd go 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. And then for 4, I would probably go 4 times 3 times 2 times 1. You don't really have to put that. The 5 factorials reduce. The 4 can reduce, how about with the 8 and give me a 2 left. 3 and 2 give me 6, so I'll reduce with that. So really I'm just left with 18 times 7. 18 times 7. We get 126. Okay, last thing here, we're going to talk about circular permutations. So what happens when you order things in a circular fashion, like around a table? All right, so for this one, we have 4 different things arranged in a circle. And though these may seem to be different permutations, they are considered the same permutation because the letters have the same position with respect to one another, right? So in a circle, it's always going to go in the same order, A, B, C, D. It doesn't matter if A is over here. A is here, then B, C, D. Okay, so they're all still going in the exact same order with respect to one another. That is, each of the 4 letters has the same letter to its left and the same letter to its right. An easy way to calculate the number of different circular permutations of n elements is to fix the position of one element. So you always have to fix the position of one element and then arrange the other n-1 elements. So for example, if you have 20 elements, you would fix one and then you would have 19 elements left to take the permutation of. Okay, so in this example, we have 4 total elements, right? So 4 total elements. I fix the first one. So there's just one way to do the first position. Like, for example, I put A there. Well, now how many ways are there, or how many things are there left to put in the second position? Well, there's going to be 3 left, right? Because there was a total of 4 things. And how many would there be then for the next position? Well, there's only going to be a possibility of 2. And how many would be left for the very last position? Well, there's just 1. And so when you do this, you end up with 6 times 1, or 6. So basically what we just did here was we took that 1 and we multiplied it by 3 factorial. So this is, we fix the first position by 1, and then we take the second position and we just say we're going to take n minus 1 and make that factorial. This is true for every single circular permutation. So we'll do number 18 here. In how many different ways could King Arthur's 12 knights be seated around the round table? Well, we take one of those knights and we fix his position. We say, you know what, we're going to take this one guy and we're going to put him there. We're putting him in the first position, wherever that first position is. It doesn't really matter. Then how many knights do I have left to position? Well, I have 11 left, and how many permutations can I do with that 11? Well, that's 11 factorial. And when you do 11 factorial times 1, let's see, let's go ahead and use our fun little math here. Oops, I was supposed to do. See, I'm slow with this. 11, and then you go math, probability, and then 4. So let's see, what is that? Let me write it down and then I'll tell you what it is. So 39,916,800. That's all the different ways that you could arrange 12 people at a table.